Let's talk about the addition rules for probability. So there may be times when you want to find the probability that either event A or event B occurs. So in this case, what you're going to do is you're going to use these rules here. The probability of A or B is, right now here's the formula for this, it's the probability of A plus the probability of B. So you add up the individuals, but then what you have to do is subtract off the, you know what I'm going to do here? I'm going to write this in terms of AND. See what this rule says? It says if you want to find the probability that A or B occurs, take the probabilities of A and B individually, add them together, but then you have to subtract off the probability that both of them happen. I'm going to change the notation just a little bit. The probability of A, now the symbol for OR is this union sign, B. All right, so these are the same, and that would be the probability of A plus the probability of B minus, and you may remember from the last section from multiplication rules, and was that symbol right there. So a quick little recap here from the last section on multiplication and this section on addition. When you see an OR, that is this symbol right here. And that's a union sign. If you see an AND, that's an intersection sign. So this is one of our addition rules. There's another one, and we'll write that right now, and that is the probability of A or B is, now just add up the individuals, the probability of A plus the probability of B, and you don't make any subtraction here. So there's two rules, one big one, one smaller one, and you can see that this smaller one here is just really contained in here. That part right there is that part right there. Let's develop these rules by looking at an example. So what I'm going to do is this. I'm going to let, all right, this is a capital letter U, and I'm going to name this set. Suppose, here's the numbers we're thinking of. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, this is called the universal set. And it's just a set of all the numbers that are under consideration. So suppose in our little universe right here, the only numbers that really exist are 1, 2, 3, 4, 5, 6, 7, 8, 9. And suppose we do this. Here's a box, and we're going to put these numbers in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the experiment is just going to put your hand in here and grab a number and pull it out and see what number that is. So let's define two events here. Let's define event A will be if the number that you pull out is a 1, 2, 3, or 4. Right? So if you get a 1, 2, 3, or 4, A occurs. B will be this event. Say 3, 4, 5, 6, or 7. So if you pull out one of those numbers, 3, 4, 5, 6, 7, then B occurs. Now suppose what we want to do is we want to find the probability that either A occurs or B occurs. So remember, A will occur if the number you pull out is one of these, 1, 2, 3, or 4. B will occur if the number you pull out is one of these. So what's the probability that either A occurs or B occurs? So let's find each one of these individual probabilities. What is the probability that A occurs? Let's see if we can write that so it's readable. All right, well, remember our basic idea here, basic definition is frequency divided by the total number of possibilities. So when you reach your hand in here and grab a number, there's 10 possible outcomes, and there's 4 ways that A could happen, right? A will happen if you get a 1, 2, 3, or 4. So there's 4 ways out of 10, so that's the probability that A occurs. And then the probability that B occurs Same idea. There's 10 possible outcomes, and B will occur if one of these numbers comes up. 3, 4, 5, 6, 7. So there's 5 of those. So there's 5 possible ways that could happen. Now, if we just add these together, if I just wrote this, what are we going to get here? We're going to get 4 tenths plus 5 tenths. Now that's equal to 9 tenths. But something's gone wrong here. See what we've done here? What if that number that we picked was 3? Right? Well, if we pick a 3, then A will occur, but also B will occur. So we've counted that one twice. And it's the same thing with the 4, right? So if a 4 gets chosen, A occurs as well as B. So we've counted something twice here. So what we're going to have to do is subtract off that double count. So what we need is to subtract off the probability that we get a 3 or a 4. All right, so what we're going to have now is really something like this, right? We're going to have the 9 tenths minus, okay, what is the probability that we get a 3 or a 4? So this would be 9 tenths minus, well, if you reach in and grab a number, there's still 10 possibilities, and there's 2 ways to get that, a 3 or a 4. All right, so it turns out then that there's really 7 tenths. So put this together, here's what we're going to have. We wanted to find this, the probability that A or B occurs. So it's not just the probability that A occurs plus the probability that B occurs, but we have to subtract off the probability that both of them occur. And that is this formula right here. Right, so the general probability rule says if you want to find the probability that or of A or B, or at least one occurs, add the individuals and then subtract the probability that both of them occur. Let's take a look at a textbook example. So here's what's going on. In a sales effectiveness seminar, a group of sales representatives tried 2 approaches to selling a customer a new car. All right, so there's a seminar and we're going to have sales reps try 2 different approaches, an aggressive approach and a passive approach. All right, so for 1,160 customers, all right, that looks like our sample size. Let's see. There it is down here. The following record was kept. All right, so you see what's going on? The aggressive approach made out of all the sales reps that were aggressive, used the aggressive approach. 270 got sales, 310 got no sales. So all together, there were... the aggressive people had 580 total, sales and non-sales. Passive, the passive people got 416 sales and 164 no sales, and their total, all right, 580 again. All right, and then they have column totals and the total number of customers. Now, what we're going to do here is, suppose a customer is selected at random from those 1,160 participating customers. Let's use the following notation for events. All right, so A is going to be the aggressive approach. A is the aggressive approach. P sub A is the passive approach. I guess P for passive, A for approach, right? PA is passive approach. S for sale, N for no sale. So P of A, that's going to represent the probability that an aggressive approach was used, and so on. Let's use the addition rule to see if we can find this probability of A or S. So that means you select a customer at random. What's the probability that that customer experienced an aggressive salesperson or actually bought a car, right? S is for sale, so actually bought a car. So we have a rule for this, and let's just write the rule. The general rule is probability of A plus the probability of S minus the probability that both of them occur, A and S. Now, what's the probability of A? Well, remember what we're doing is we're choosing a customer at random. So there are 1,160 customers, and how many of them experienced the aggressive approach? Well, the aggressive approach total of 580 possible aggressive approaches. Plus, now what's the probability of S? Well, S is sales, right? So there's still 1160 people to buy cars, and sales, well, those occurred what? Well, sales, those occurred what? Right here, right? There were 686 total sales. Minus, now, what is this one here? This is still going to be over 1160. So how many were both aggressive and sales? So look in your table here. Aggressive and sales, right? Aggressive and sales. That would be 270. All right, so all the same denominator. So we're going to get the 580 plus 686 minus the 270. All right, and my calculator is showing that I get 996 out of 1160. All right, so I'm going to declare that to be the probability of A or S.